The current state of AI vision models. Look up from your screen for a moment. Scan the room you are in. Your visual intelligence system perceives the room and its contents, comprehends them, and thinks about what to do, if anything, in real time. Executive summary. Artificial intelligence is getting much better at seeing and understanding the world. AI vision models are systems that learn from images and videos. They can identify objects, describe scenes, and even create new pictures or videos from text prompts. In 2025, these models are appearing everywhere, from phones and cars to hospitals and classrooms. This summary explains how the field developed, where it stands today, what challenges remain, and what's coming next. From CNNs to transformers. For years, computer vision depended on convolutional neural networks, CNNs, which scan images with small filters to find patterns like edges and shapes. Around 2020, the Vision Transformer, VIT, changed that approach. Instead of scanning small areas, it breaks an image into patches and studies how they relate to each other, capturing long-range details. This method scales better, improves accuracy, and allows reuse of models across many tasks. Linking images and language. A major leap came from connecting pictures to words. Models like CLIP were trained on huge sets of image-text pairs, letting them understand language and visuals together. This allows zero-shot learning, for example, recognizing a robin even if it wasn't trained on bird photos, just by knowing the phrase "photo of a robin." Because of this, users can now control vision models with natural text prompts, making them flexible tools for many jobs. The rise of multimodal AI. The biggest trend in 2025 is multimodality, models that combine text, images, audio, and video. OpenAI's GPT-4o and Google's Gemini 1.5 are key examples. They can look at a picture, read any visible text, reason about what's happening, and answer questions in plain language. Their long context windows allow them to process entire documents, slide decks, and videos. Students can upload science handouts and ask questions about diagrams, while support agents can use screenshots to get step-by-step troubleshooting help. Precise understanding, segmentation. Beyond classification and detection, vision models now excel at segmentation, drawing exact outlines around objects. Meta's segment. Anything two can identify nearly any object in an image or video with a simple prompt. This helps editors remove backgrounds, sports analysts track players, and researchers map coastlines or forests over time. Better segmentation tools also make it easier to build labeled datasets, speeding up research and lowering costs. Generating images and videos. Modern models don't just recognize images, they create them. Generative vision systems like Stable Diffusion 3 follow detailed prompts, keep multiple characters consistent, and even handle typography. Text-to-video tools can now produce minute-long clips with realistic motion, lighting, and camera effects. Filmmakers use them for storyboards, teachers for animated lessons, and designers for product demos. Many also support video editing by instruction, letting users change colors, lighting, or backgrounds just by asking in plain language. Running on everyday devices. Another key shift is making these systems smaller and faster so they can run on phones and laptops. Thanks to techniques like quantization and optimized compilers, apps can now caption photos, scan documents, and translate text directly on a device, without cloud servers. This boosts privacy, lowers costs, and works better in areas with weak internet. Many apps use hybrid systems, local models for speed, and cloud models for harder reasoning. This mix gives users quick, reliable experiences almost anywhere. Real-world applications. AI vision is already helping many industries. Healthcare. Models flag early signs of disease, compare scans over time, and assist with triage in busy clinics. Doctors still make the final call, but AI speeds up checks and reduces workload. Transportation. Cameras help cars detect pedestrians, stay in lanes, and monitor driver attention. Robotics and industry. Vision guides warehouse robots, sorts packages, and inspects crops or factory products for defects. Retail. Smart cameras count inventory, power self-checkout, and find flaws on production lines. Accessibility. Apps describe scenes, read menus, and turn signs into speech, helping visually impaired users navigate the world. These systems work best in controlled settings with clear goals. Performance drops in poor lighting or unfamiliar locations, so human oversight remains essential. Successful projects define narrow tasks, test in real conditions, and update models regularly as environments change. Ongoing challenges. Despite progress, Vision AI still faces major issues. Robustness. Models can make mistakes when lighting, angles, or cameras change. More diverse training data and stronger testing can help. Bias and fairness. Public web data often reflects social bias. Without careful audits and targeted data collection, models may perform worse for certain groups. Temporal reasoning. Understanding a single image is easier than tracking events over time. Long video reasoning and memory are still being developed. Hallucinations. Multimodal chat models sometimes describe things that aren't really there. Researchers are adding retrieval tools and step-by-step reasoning to improve reliability. Combating misinformation. As AI becomes capable of making photorealistic images and videos, the risk of deepfakes grows. One major response is content provenance, attaching secure metadata that shows how a file was made and edited. The C2PA standard defines these content credentials so platforms can verify authenticity. The U.S. National Institute of Standards and Technology, NIST, also catalogs detection and watermarking methods to help fight misinformation. The best approach combines visible labels, verified provenance, user education, and clear platform policies for altered media. What's next? Several trends are shaping the next phase of vision. AI, better video generation. Expect sharper, longer clips with more control over movement and lighting. Advanced editing. Users will guide creation with sketches, reference photos, or example clips. Vision-enabled agents, future AI assistants, will use live video to perform real-world tasks, checking gauges, identifying parts, or guiding robot arms. Human supervision and safety layers will be critical. Custom small models. Companies will train lightweight versions for specific needs, such as spotting factory defects or reading proprietary forms. Improved evaluation. New benchmarks will focus on reliability and transparency instead of just accuracy averages. The bottom line. AI vision has evolved from research demos into dependable tools. Transformers and image-text learning created the foundation. Multimodal systems made visual reasoning easier to use. Segmentation and generative tools opened creative and industrial workflows. Challenges like bias, robustness, and misinformation remain, but progress in safety and authenticity standards is strong. In the coming years, the best systems will blend powerful vision skills with clear safeguards and practical design. Models that combine ability, safety, and real-world usefulness will shape how we see and how machines see our world.